Hello everyone, welcome once again. Welcome to the part 2 of our moving our model to production. Here we'll be discussing about the dependency inversion rule. We'll be talking about how we need to start bringing our API together. So like we've said, our core part will contain our inference pipeline. Let's close our domain. Our core part will contain our inference pipeline, and it will contain our model. It will contain our main implementation of the inferences, and we have the interfaces part in domain, right? Like we saw, it contains abstract contracts, no Python, and our core part depends on the interfaces. So even if you change the actual implementation that inherits your interface, it would still not break because you have to align with your interfaces. Again, our infrastructure part would be the part that will connect to our database, like we've seen, our database, our machine learning models part, our repository that connects to our database, our storage that we are going to use to store our images in a cloud storage bucket. So, but we'll need to define our container before our next session so that we can start seeing how things will come together. Again, our DI container is going to be where we define our dependency injection. Define all our dependencies, and our contains our dependency injection. We'll be updating that documentation as we proceed. So, and what we'll be using now is do we have our dependency injection here? No, we do not. Dependency injection. Let's confirm. Dependency injection PyPy. Oh, dependency injector, sorry. So let's fetch this, and let's come here. So let's copy this. So our dependency injector. So we come to our container here. This is not our Docker container, right? This is our container for our dependency. So don't mix that up. From dependency injector, import our containers, then import our providers. Again, you can only know this when you go through the documentation. So, but from src.config .settings, import get settings. Then we then need to have our model from src.infrastructure.ml. Yes. The model loader. Import what? Our model bundle and our load model. We then need to have our TorchRunner from src.infrastructure. No, this is wrong. Infrastructure.ml .TorchRunner import what? Import our TorchRunner. Normally we should have our ONNX runner yet, but we don't have it yet. Maybe in our subsequent video this would be ONNX runner, but let's just comment that out. That is not available for us to use. So we then need to, for now, okay, let's proceed to setting up our container. So let's just have like a build runner here in case we eventually add our ONNX runner. So build runner, it takes the model bundle, okay, we have our model bundle. We have our class names, which is list of strings, and we also have our image size. Image size is going to be an integer. So for now, because we do not want to use ONNX, we just have to return our TorchRunner for now. TorchRunner model is equal to model bundle dot our model. So we then have to define our container. So which we take in our containers dot our declarative container. So we then have to define our config, which is what? Our provider. We create a singleton of our settings. Singleton of get settings. So just a brief insight into how our container works. When you're using your provider.singleton, it means for your entire application lifecycle, only one instance of that thing will be created. What does that mean? Only one instance of our settings will be created. We don't have to create settings for every request that comes into our API. So we are going to define our database here eventually. Database. We are going to define our model. Let's define our model bundle now. So we then have this as our model bundle is equal to, again, we only want one single model bundle in our entire application lifecycle. Because let's assume that your model, you have a very small GPU and you want to run several model instances. So it is best to just have its providers.singleton. We are going to use factories for some other things. Why? Factory is when you want a new instance of that thing to be created for every request that comes in. So load model, and you then pass in your settings as your config that you've loaded. Okay, so we then create our runner, model runner. We then say our runner is what? Providers.factory. Again, we want to create multiple runners. We need to understand that we've loaded our model. We are not reloading our model. We are just creating several runners, like several runners for each request, like a single runner for each request. So we don't create a single thing for that. So we then say build our runner. This should be local to this, so that should be build runner. Then we say our model bundle is what? Our model bundle is what? Is our model bundle. We then have to do class names is equal to, we need to get the class name from our config in our settings. For dependency injection, there is a pattern to it, and you can only know it due to use or checking the documentation. So let me write that down. Providers.callable. Yes, lambda of your config. Then get your config dot your class names. As you can see, class names. Then pass in the config through a lambda function. We then have to get our image size too. So let's just copy this. Providers dot class is its image size now. image size. We can then have this as, okay, this is our, what's our image size here? Okay, yes, this. Let's fetch it and let's just update that part. So we've started building we've started implementing the building blocks of our dependency injection container, and we'll see how this comes through. Now let's look at something interesting here. For example, if I added the ONNX here, it will still work. Why? Our model runners, they are all told that they all need to implement run inference no matter what happens under the hood. So if we add an ONNX runner, it would have a run inference no matter what happens there, that also takes in image parts and returns detection. So that's one of the beauty of ensuring your code follows the clean and solid principles. So let's start building the building block of our FastAPI application so that we can start seeing how some things come into play before we go deep into our DI. So this is our main fruit detection FastAPI entry point. So we import from context lib. We import our async context manager. Then from FastAPI, we import our FastAPI. Yes, no. Yes, we then, for now, let's create an L router. Let's create an L router to make this more interesting. So we have a new folder here, which is API. Before we get to that, let's come back here. So let's import our DI container from src.config.container. Oh, do we have it? Where is our config? Yes, the container. Import what? Import our actual container. So we then have to import our settings from src.config.settings. Import our get settings. So we then have to import our logger to here from utils.logger. Import get logger and define our logger here as equal to get logger. Okay, so we then have to define our settings to our settings is equal to what get settings for when we need some things there. So we have to define our container to our container is equal to our container. Eventually, because I've gone through the documentation, I know I have to wire our container eventually, but let's prepare the base implementation of its container. The wire, you wire your routers, your router has modules through there. Modules is equal to, you then add your routers here, but let's leave it for now. Routers, then you have to define your API lifespan with an async context manager. Async context manager, you then do your async def, define your lifespan of your API. Then it takes in the app, which is our FastAPI application. Then you do logger.info, starting up our API, starting up our fruit detection API. Then the first thing we need to do now is we need to ensure that for every time our API starts up, we want to load our model. Why is that important? Your model loading is, no matter how small your model is, your ML model is an IO operation when it comes to this. And you want your API to be so fast that even though it starts now, every inference coming through your server should be fast. So what does that mean? You want to preload your model as API starts up, so that when inference comes, you don't have to reload your model or load it for the first time when you get your first inference when your model starts up. So what do we, so starts up model in API startup. So we then do our bundle is equal to what? Our container dot our model bundle. Okay, so we then do our logger dot info active model is what? Our bundle dot model, and the format, let's even load the format before. Active model format is what? Our bundle dot format, and the model is our bundle dot model. Okay, this is getting cool. So we then yield our application. Important, you can only know this when you how would I call it? You can only know this when you go through the FastAPI documentation. Everything is there. In fact, let's check it. FastAPI PyPy, and let's go there. So if we go through this, we can see that you can define your FastAPI application. You can have your routers and routers defined, and you could also, these are implementations. They didn't have the lifespan. Okay, you have to go through the docs extensively to find out the lifespan, but let's not waste time. So we have yield. After our model starts, we also have to do something like initializing our database engine. So when our API shuts down, when you shut down our API, we then have to also say shutting down API, our full detection API. So we have this as yes. So we then have to, now if we had started our API, we then have to dispose our API, our database rather, dispose our database. So we have to define our app now. App is what? FastAPI. Then we say the title of our API is what? Title of our API is what? Settings dot app name. Since we know we have that, our version is what? Our settings dot version. Our lifespan that we defined is our lifespan. We then say our docs URL is what? Our API settings dot API vstring, then /docs. We have to do this, and we have to do this. Yes, interesting. So we then have to attach our container to our app. App.container is what? Our container. And let's now have our else. Before we have our else endpoint, right? Let's just do if name equals main, start up our FastAPI, import our Uvicorn, and do our Uvicorn .run our main app. Yes. Then we say our hosts is 0.0.0.0. Then we say our port is what? Our settings the port. Then reload. We don't want it to automatically reload for every update that we do in our code base. Then we then say our log level for even the API is what? Our settings dot log level dot lower, and let's try to start up our API. So Python main.py, let's see if we have any bugs. FastAPI, not FastAPI. That was wrong. So it says a module not found error. FastAPI. That was terrible bug. So it says we do not have settings. Module not found. SRC config settings. Why is that? Even though we have, oh, my settings name was so incorrect. Settings, yeah. So let's just clear our terminal and start our application once more. Let's wait for it. Wait for it. It's about to start. Okay. It's about to start. Oh, so we have a bug. It says module not found, src.infrastructure. Where is that happening in our TorchRunner? That was wrong. Okay. Okay. It does not found interfaces. src dot, oh wow, this is in domain, not infrastructure. That was a buggy import. Oh, it says container. Wow, I got that wrong also. Container. Okay. Let's start up our application once more. Oh, my log level spelling is also wrong. Wow. Let's fix that. Okay. Let's start up our application. As you can see, our API is started up. We have our model. We have our format, which is PT, and we have our app running. So let's check our docs page. Which port is our app running? Port 8000, localhost 8000. That is wrong. We have API v1 docs, and where do I find this? We have it in our settings that our API string, which is preceded by our docs here, or our docs precedes it, whatever. So as you can see, we have no router, no endpoint router here. So before we close out this video, let's add a health check endpoint here, and let's see how that goes. So for every router, let's say we have our health page here, our health, and we have our prediction here. Prediction. No, this should be inside API, not in health. Inside API. Okay, let's delete it. That is wrong. Prediction. So let's add an health router here. Router.py. Okay. For our health router. So this is what? This is our health check endpoint. So let's do from FastAPI, import our API router. Then we do router is what? Our API router, and say that is this is our health tags. This is our health check. For health check, health, okay. Then we define our health router. So we do at router. Have I imported? Okay, yeah, we have it. We have our router here. At router.get, which is our health. Then we do async def our health check. Normally we should add a database check into this health check, but we are not adding it for now. So this returns a dict. Let's import dict from typing. typing import dates. Okay, it returns a date and it returns status is LD. Is LD. Our API is LD. So let's start up our application. Our router, our docs will still be empty, and there is a reason that is. So let's now come here. We have to attach it to our main application in main.py. So which is why we then have to do something like import our routers from src.api. We have it in API, right? We then have it in health.router, import router as health router. So we then have to include it, or before we include it, let's attach it as a module into our wired container. srt.api.health.router. We add it here, and we also need to include router in our API. So this is where we include our routers. Include as many routers. Include routers. So we then have this as app.include router. Yes. We then call this as our health router. And we have to prefix it because we have our API string. Prefix is what? Settings.api vstring. Let's restart our API. Let's uncomment out this model. Let's uncomment out this model since we don't need it. Let's just remove it. We don't need to see our convolutions and things like that. Let's just add our model format. Let's start up our API. It says I do not have SRC here, so I guess I have to import that. So import SRC, and let's see how that goes. We have our API started up now, so let's load our docs, and voila, we have the health check endpoint on our docs. Let's try it out and see that our API is LD. So we will be discussing further on our inference pipeline on our DI container wiring in our next video. Don't forget to like, subscribe, and share.